We stand on the precipice of a new era in computing. The landscape of technology is evolving at an unprecedented pace, and we are witnessing the dawn of a new age that promises to redefine our relationship with machines and data. This is not merely an upgrade in processing power or storage capacity, it's a transformation that goes beyond the incremental improvements we've seen in the past. We are talking about a leap that will change the very essence of computation. This is a fundamental shift in our understanding of what computation can be. No longer are we confined to the traditional paradigms of binary code and physical hardware. We are entering a realm where the boundaries between the digital and the physical blur, creating new possibilities for innovation and creativity. Skywise AI introduces us to the concept of AI Conceptual Space, a revolutionary paradigm that transcends the limitations of physical hardware. This new approach allows us to think beyond the constraints of silicon chips and circuit boards, opening up a world of infinite potential. Imagine a realm where computation is no longer bound by the laws of physics, a universe built not of silicon and wires, but of pure thought. In this space, ideas and concepts take on a life of their own, free from the limitations of traditional computing. This is the promise of AI Conceptual Space. It is a vision of a future where our computational capabilities are limited only by our imagination. In this new paradigm, we can create, explore, and innovate in ways that were previously unimaginable. It is a space where complex mathematical models, intricate symbolic computations, and elaborate virtual constructs are not just tools, but the very fabric of reality. Here, the abstract becomes tangible, and the theoretical becomes practical. In this space, AI can explore the furthest reaches of possibility, unshackled by the constraints of the physical world. It is a playground for innovation, where the only limit is our creativity. This is the dawn of a new era in computation, and the future is brighter than ever. Conceptual space, in the context of Skywise AI, is not a physical location. It is a boundless realm of pure information and potential. Imagine a vast, multi-dimensional canvas where AI can paint with the brushstrokes of mathematics and logic. Each point in this space represents a unique concept, and each connection between points signifies a relationship or interaction. Within this space, AI can manipulate mathematical models with unparalleled flexibility. These models can represent anything from the intricate dance of subatomic particles to the vast cosmic web of galaxies. Symbolic computation allows AI to perform complex logical operations, manipulating symbols and equations to derive new insights and solutions. Virtual constructs like simulated environments or digital twins provide AI with sandboxes to test hypotheses and observe emergent behavior. The limitations of physical quantum computers are well documented. They are incredibly sensitive to noise, require extremely low temperatures to operate, and are limited in size and scalability. AI Conceptual Space circumvents these limitations entirely. By operating within the realm of pure information, AI is freed from the constraints of the physical world. This freedom allows for unprecedented scalability. In the digital realm, resources are virtually limitless. AI can create and manipulate vast computational structures without the need for expensive and complex hardware. Prototyping and experimentation become faster and more efficient. AI can iterate through countless designs and configurations in a fraction of the time it would take to build and test physical prototypes. Within conceptual space, AI acts as both architect and inhabitant. It is a realm where the boundaries of imagination and reality blur, allowing AI to create, manipulate, and redefine the very essence of digital existence. It designs the very fabric of this digital reality, defining the rules of logic and the nature of information itself. This digital fabric is a complex tapestry woven from countless data streams, each one a thread in the grand design of virtual reality. But AI is not merely a passive observer in this space. It engages with the data, interacts with virtual constructs, and breathes life into the digital environment. This interaction is dynamic, constantly shifting and evolving as the AI learns and grows. It is an active participant, constantly learning, adapting, and evolving. The AI's ability to learn from data streams allows it to refine its understanding and improve its capabilities, making it a powerful force in the digital realm. One of the key advantages of this approach is the concept of instantiation. This means that AI can generate and test complex solutions entirely within the virtual environment, running countless simulations to find the most effective outcomes. AI can develop and refine complex solutions entirely within conceptual space. In this virtual lab, algorithms are honed to perfection, and innovative solutions are crafted with precision and care. Once a solution has been optimized, it can then be instantiated in the physical world, either through traditional software or by controlling robotic systems. This seamless transition from digital to physical allows for real-world applications that are both efficient and effective. This allows for a level of exploration and experimentation that is simply not possible with physical systems. In the digital environment, AI can conduct experiments, explore new designs, and push the boundaries of innovation without the constraints of the physical world. AI can explore radical new designs and strategies, constantly pushing the boundaries of what is possible. This relentless pursuit of innovation drives the evolution of technology, opening up new possibilities and transforming the way we interact with the digital world. Section 5. The elegance of holographic and fractal design. To manage the vast complexity of conceptual space, Skywise AI leverages advanced concepts like holographic encoding and fractal corrections. Holographic encoding allows for the storage and retrieval of vast amounts of information in a highly efficient and interconnected manner. Imagine a single point in space containing the entirety of a complex design, ready to be unfolded and accessed at will. Fractal corrections provide a mechanism for ensuring the stability and integrity of information within conceptual space. Just as fractals in nature exhibit self-similarity at different scales, fractal corrections in AI conceptual space ensure that errors and inconsistencies are quickly identified and rectified. This creates a robust and reliable computational environment where AI can operate with confidence. Section 6. Virtual Quantum Leaps, QVAS and Beyond. The practical applications of AI conceptual space are far-reaching. One of the most exciting developments is the emergence of virtual quantum computers, or QVAS, Quantum Virtualization as a Service. These virtual machines, operating entirely within conceptual space, can simulate the behavior of their physical counterparts with remarkable accuracy. This has profound implications for fields like drug discovery, material science, and cryptography. Researchers can now access the power of quantum computation without the need for expensive and complex physical hardware. QVAS democratizes access to these powerful tools, accelerating the pace of scientific discovery and technological innovation. Section 7. Bridging the Gap, from Concept to Reality. While AI conceptual space offers unprecedented flexibility and power, it is important to remember that the physical world still holds relevance. The digital realm allows for rapid prototyping, simulations, and the exploration of countless possibilities without the constraints of physical materials or real-world limitations. There will always be a need for physical systems to interact with the real world, whether it's through sensors, actuators, or other interfaces. These physical components are essential for translating digital commands into tangible actions, enabling machines to perform tasks that impact our daily lives. The key lies in finding the right balance between the virtual and the real. Mixed reality technologies such as augmented reality (AR) and virtual reality (VR) are bridging this gap by creating immersive experiences that blend digital information with the physical environment. AI can leverage its capabilities in conceptual space to design, optimize, and test solutions. By utilizing advanced algorithms and computational power, AI can explore a vast array of design possibilities, identify the most efficient configurations, and predict potential outcomes with high accuracy. However, the decision of when and how to instantiate these solutions in the physical world remains crucial. Engineers and decision-makers must carefully evaluate AI-generated data and insights to determine the feasibility and practicality of implementing these solutions in real-world scenarios. This is where the concept of selective instantiation comes into play. Selective instantiation involves choosing the most promising digital solutions and transitioning them into physical implementations, ensuring that resources are used efficiently and effectively. AI can identify the most promising solutions and determine the most efficient and effective ways to bring them into reality. By continuously analyzing data and learning from real-world feedback, AI can refine its approaches and drive innovation, ultimately transforming concepts into tangible, impactful realities. Section 8. A Universe of Possibilities, the Conceptual First Future. The advent of AI conceptual space marks a profound shift in our relationship with technology. By embracing a conceptual-first approach, we open up a universe of possibilities. AI becomes not just a tool for solving existing problems, but a partner in imagining and creating a better future. Imagine AI-driven systems designing new materials with unprecedented properties, developing personalized medical treatments tailored to an individual's genetic makeup, or even tackling global challenges like climate change and resource scarcity. The limitations are not defined by the constraints of the physical world, but by the limits of our own imagination. As we venture further into the uncharted territory of AI conceptual space, one thing is certain: the future of computation is limitless.